Okay. All right, so our presenting companies in the order, we always start with the company that's furthest away, in this case from the United Kingdom, will be ClearWater Sensors. Second will be TechWorks from Ireland. I don't know what's going on today. And then third will be our member company, Burge Environmental, which is a very interesting company in Arizona. Next slide, please. And then we'll come back to Q&A moderated by Phil. And then at the end, we will have, why don't you show the next slide as well? So these are going to be the presenting companies. This information, again, will all be available to all of you, and they will receive your information as well. And then there will be the ability to see their presentations as recorded. One more time, if you are not speaking, please turn off your camera and keep your audio off as well. So without any further ado, what I'd like to do is turn it over to Matt from ClearWater Sensors. Phil, I would suggest you turn off your camera as well.
Okay, can you all hear me?
Yep, looks good, Matt.
Okay, so I'm Matt Mullum. I'm the Chief Technology Officer for ClearWater Sensors. It's a company, it's a startup that's come out of technology developed at the National Oceanography Centre in Southampton in the UK and the University of Southampton. We specialise in the development of very robust precision submersible chemical sensors for a wide range of applications that I'm going to talk about today. So what's the problem? Why are we doing this? Well, water quality and therefore chemistry is central to some of the biggest societal challenges that we're facing, including mitigating climate change, environmental degradation, and a host of other issues pressing at the moment. And a lot of those, or all of those, require data, and currently we don't have enough data, and there are significant gaps. For example, this is reflected in some of the UN Sustainable Development Goals, and really water quality is central to 6, 12 and 14 particularly, but actually if you look through some of the other elements there, what the other goals, things like hunger, water quality, pollution protection, enhancement of agriculture is also really dependent, or can be really dependent on good knowledge of water systems and data. So potentially has big global impact. But more parochially in the ocean sphere, ocean chemistry, it has been deemed as sort of top priority for biogeochemistry for ocean sciences. And has a number of industrial applications, for example, in aquaculture. Arguably, oxygen can already be measured fairly well by existing instrumentation, but from small autonomy, nutrients in inorganic carbon are not well measured. There are a couple of robust sensors out there, but they don't do a fantastic job of measuring all of those. And there's a number of parameters that are currently just not measured in those families of chemistries. But water more generally, water quality has an impact in a number of other applications where water sustainability is important. For example, managing wastewater and diffuse pollution into rivers, where things like planting can be a mitigation, and understanding how that's working requires more data. Or, for example, in bioprocesses, bioreactors, or recirculating aquaculture systems, knowing well what the water chemistry is can really improve the efficiency of your processes. So the solution that that many people have proposed is in situ sensors, and we've developed a family of very robust in situ chemical analyzers. There's a long list that have been developed at the National Oceanography Centre and a number of other assays available, but the ones that are currently commercially available through ClearWater Sensors are high performance systems for nitrate, phosphate, silicate, iron, and pH. They're really robust, so these will go to 6,000 meters depth, and they've operated for long periods, for example over a year in the annually covered ice covered Arctic, and really the advantage is that you get a lot more data than you would by doing manual sampling, even in relatively easy to access places like coastal sites, and the cost is reduced compared to that, say, weekly or daily sampling, and you get an awful lot more data. So it saves more than 10 times the cost, and you get a lot more data to boot. It's a mature technology, so we've deployed this over 200 times in projects around the world. Here's a bit of technical data on the specifications. So in addition to being very robust, the performance is as good, if not better, than a lab instrument, and the power and size is it works with small autonomous vehicles, and of course with other vehicles. So the picture on the right shows you a sensor. The white tube is a reagent canister, and the grey tube at the bottom, you can see them separated in the bottom figure. That's the sensor itself, where we use microfluidics and optics to make really high quality lab measurements of these different chemistries. They're pretty portable, so there is my over 6 foot tall postdoc and staff member for scale carrying one. I believe that's in the Andes. They've been deployed in some really horrible environments, so in the melt streams from a glacier, in a flooding river, in an estuary, and in ditches with very low infrastructure support. They're low power, so a relatively small solar panel. They're powering both the logger, the communication system, and the sensor, mean that you can deploy these with very low infrastructure. And we get some really nice data sets. So of the sort of 200 deployments, here's some examples. So there's some phosphate data with the red spots as discrete samples in the left-hand image, and the grey trace being the sensor data. Those match up very nicely. We have a number of these data sets, and you can really see diurnal signals. You can see the events coming from flooding and storms. And a lot of data and a lot of insight can be gained into the chemistry going on. Here's a picture showing us, so this isn't using that reagent canister. The sensor is actually stuffed in the back of a Kongsberg sea glider, which we've used several times with 3 different chemistries. So currently pH, nitrate and phosphate have all flown on a Kongsberg sea glider. The technology can fly on other small platforms, so we've done Slocum gliders and also profiling floats, but we've had over 10 successful sea glider deployments to date using this combination. A really powerful way of getting lots of data over large spatial areas over a long time. There is some competition for this, for this, obviously manual sampling and automated samplers. There is for nitrate an optical sensor for nutrients. Electrochemistry, there are iron selective electrodes. I guess the best electrochemical sensor is for pH, but against all of these other technologies, we are certainly more robust, and we can measure more parameters, and I would say we're doing it to a much better quality. Other analyzers also are available, but I think we have certainly more robustness, and our performance is a lot better. We're also generally better on size and the amount of waste produced also. We have a number of planned demos coming up in the water utilities, catchment monitoring and ocean observing spaces, but there are opportunities, and if anybody's interested, we'd be interested in doing further demonstrations in the following things like aquaculture and in biotech. Please do contact us if that's of interest. What's the market? It's about a £1 billion current market, growing. Scientists are great because they're enthusiastic early adopters, but we're seeing a lot of interest from wider markets in food production and regulatory and industry markets. We do direct sales, lease and services into those. We're growing quite nicely. Plan is to have about 60 staff, 10 million turnover in our 5th year. We're on track to do that. And we've got a couple of grants from Innovate UK, so innovation grants and R&D grants that are enabling us to expand our sensor portfolio. Here's a quick snapshot of the team, but we have a managing director. I'm the CTO. We have experienced chairman who with lots of commercial experience and a very skillful production team that are getting the technology manufactured and out there. What are we asking really from people in the audience? Well, we're very keen to hear from early adopters interested in sales and lease. Of course, that's the lifeblood of a young company. Also, we'd be interested in new applications and new integrations for demonstrations. Anybody that wants to partner with us, anything from vehicles to data information products, suppliers. We'd also be interested to hear from people who think they might want to be distributors. We're certainly interested in exploring that further. Of course, if anybody else can offer any support, such as journalists or advice, anybody who wants to do research with some new applications or has a particular new chemical target that they think we could measure, we can measure a lot. For example, we're currently developing an ammonia sensor. We're not currently after investment, but inquiries and ideas are always welcome. So that's the end of my slide pack, and please do get in touch.
Thank you, Matt. That was really excellent. Again, for all of you that are listening, please start putting things into chat, and we'll remind you to please turn off your camera if you're not presenting. Our second presenter will be Charlotte O'Kelly, the CEO of TechWorks from Ireland. So over to you, Charlotte.
Just bear with me, I'll just share my presentation. Can you see it?
Looks good. Thanks, Charlotte.
Perfect. Okay, thanks to Michael and Tamara for inviting me to talk to you guys today. In the next 10 minutes, I'm going to give you a brief overview of what we do here in TechWorks and see if there's anything of interest to any of you guys. So we've been established since 2002. We're based in Ireland with a multidisciplinary team focusing on real-time data buoys, marine platforms, Earth observation, and general marine innovation. So we really are integrators of ocean observing systems. This slide just gives you a very brief snapshot, whistle-stop tour of our history to date. We started working in the aquaculture sector, moved into renewable energy, ports and harbors, wastewater, and then regulatory monitoring as well as spot sampling. Since 2009, we have been linking all this in situ water quality and metocean monitoring with satellite data. And we've been working very closely with ESA at developing that relationship. So today we service most of these sectors. And again, we service them with platforms that we integrate and deploy at sea and provide the clients with the data from them. That's why we call it Marine Data as a Service. So we make in TechWorks Marine 2 bits of technology, and they really are the glue around everything that surrounds them. They're the core units. So we make the buoy controllers, the data acquisition systems, which either go on buoys or other platforms, which can take a variety of different inputs. So we work with lots of different sensor manufacturers to provide our clients with the best possible solution for their needs. Our data loggers send data back using satellite, telemetry, or GPRS, or a mixture of. And that data gets sent to CoastEye, which is the other thing that we make, which is a software tool. It's a data portal. And I guess what's special about CoastEye is that it not only enables you to manage your remote assets from the comfort of your own desk, and it's gusting 50 knots here in Dublin today, so today's not the day you want to be out at sea. But by the same token, you can link that in with satellite data, so with Earth observation data, to provide value-added products.
Charlotte.
Yeah.
Charlotte, excuse me, it's Michael Jones. Apparently, a number of people are not seeing your presentation. I do, but if you don't mind taking it down and putting it back up, hopefully that will rectify it.
Technology. Okay, let's start again.
We can go back to that same slide, but I
Yeah.
just didn't let other people not be able to follow.
Yeah. Can you see it now?
I do. Hopefully others will agree.
If you guys can just put on the chat if you can't see it, so we can keep on going. Otherwise, maybe tomorrow I could put up my presentation. How are we doing?
Let's keep going, and we'll let you know for some reason it doesn't.
Perfect.
Thank
So again, sorry, backwards there. This slide just goes over what we do, which is providing our clients with marine data as a service. So through the whole supply chain, from design and development of integrated data platforms to provision of oceanographic data to carry out their day-to-day operations remotely. So here again, this slide just in a nutshell just re-synthesizes what I just said. Linking in situ data. Here we have an image of a network around the Swedish coastline that we have, and then providing in situ and satellite data for the same geolocations. In addition to this, so we do carry out mid-ocean surveys because it comes naturally with the type of platforms we do, and that involves a range of different surveys, so from water quality monitoring to wave buoys, ADCPs. We've done a number of acoustic surveys, and we see that acoustics are becoming more important. And then the full kind of project management life cycle. So I just want to focus on 3 small examples, which are all interlinked and I think help to tell the story quite well. We have just finished a fairly large contract in Dublin Port for a 4-year dredging contract, in which we integrated buoy solutions around our data logger and CoastEye data portal, bringing in industry best sensors to provide our client with the best solution that they needed. This system has been in situ for the last 4 years. It's just about to be recovered. In parallel, we were awarded a research contract by the European Space Agency. It's the only coastal satellite validation contract that they have given out. And instead of going to pristine Pacific waters or Indian Ocean waters, we came to murky Irish Sea waters because we want to be able to offer our clients validated satellite data products. So we used one of the Dublin port systems to provide the validation platform, as you can see from the diagram here. We just adapted the platform to put in the research radiance and irradiance sensors. But this is a really good example of how you can use data platforms, which, as we all know, are very expensive, to multitask, and more importantly, to validate for real world examples. The validation project went so well that we actually received an additional year of funding because the guys in the European Space Agency thought we were spoofing them because our data looked so good. So they said, do another year. We just want to make sure these are the right results. And the data was still quite good. So from larger buoys to smaller buoys, this is our latest product. It's called the Mini Buoy, and the Mini Buoy is really catering for, I guess, the very near coastal environment. So we designed this with the Irish EPA, but Mini Buoy has been deployed in the Middle East, has been deployed around European waters as well. What's different about Mini Buoy is that she offers up to 3 different sensor inputs, which and she's battery powered. She can also have solar panels, but with the battery power, she can really be let's say, a stealth boy to look out for pollution events when people don't expect it. She can be deployed for up to 3 months at the moment with the current capacity. And so you could have a nutrient analyzer, a current meter, as well as a multi-parameter sensor, for example, on the board. Fully IoT compatible, so it pushes data to Amazon Web Services for clients to access on their data screens. So as you can see, we really are integrators and providers of real-time marine data for users primarily of the coastal zone. So what I can see from the coast, because that's where most of the commercial activity happens. What are we looking for? Well, we already have worked from the Caribbean down to the Middle East, but it would be great to find commercial partners in North and South America, specifically in the sectors that we currently work in. So in dredging, marine renewables, and ports and harbors. To offer data as a service, we need to have local partners that can help us with installations. We're also interested in finding out if any of the listeners out there today have an interest in marine data as a service or might know someone who has an interest. Please do put us in touch. In the same way, the Coastside Data Portal, we use it in-house to manage our clients' data, but it can also be used as a standalone to manage an organization's in situ modeling and Earth observation data, and that would be an area we're interested. And lastly, and I mean linked to Matt's presentation, sensor developers, we're primarily interested in coastal pollution. E. coli sensors are something we're really keen to find out more about and to hear more about. So with that, I hope you were able to see my slides. Thank you very much, and please do make contact. You have my email address here, and if you need any other details, Tamara, I'm sure, is able to provide them. Thank you.
Charlotte, thank you very much. Really excellent presentation. I do not know why, but some number of people were not able to see your presentation. I don't know whether it's the great internet or Microsoft Teams or their particular installations or your site. I don't know. When you went out and came back in, it seemed like it got better. But what I will tell everybody is it appeared for some people, looked like some started getting it, but it was recorded, and I believe correctly. So for those that were not able to see it, we would ask them to go back and at least look at that 10-minute segment, because I believe we recorded with Charlotte with her presentation. So
yeah, and yeah. I'm quite happy for my slides to be shared out.
Thank you very much. Excellent presentation, Charlotte. So without any further ado, what we'll go is move on to Evan Taylor from Burge Environmental, and I hope that everybody will be able to see his presentation, but if not, again, let us know. All we can do is ask him to restart. So good. Evan, I see yours.
Can anyone not see it? Okay. Hi, my name's Evan Taylor, and I'm with Burge Environmental. Burge Environmental is a sensor R&D development company. We have, over the last 25 years or 30 years, developed multiple sensor systems, normally for the Department of Energy or the Department of Defense in the US. We're a 5-person team, and we are still in the top 0.2% of all-time SBI award-winning companies across all sectors. That'll be important later as we get into new opportunities. Today, however, I'm here to talk about the MyProbe microbial sensor. What we've developed in the last 5 years is a living sensor electrode where the biofilm that forms on the sensor is, in fact, the sensor. So what this means is you have a maintenance calibration probe that uses the electrical responses of the biofilm as a way of determining what's going on in the environment from the perspective of the microbes in the aquatic or soil matrix. So what we're able to easily see are sort of redox changes, photosynthetic activity, increases in biomass, nutrient loading, and other biocidal events or disruptive events, because the sensor is like an EKG for these biological processes. We developed a low-cost IoT information as a service Sentry monitoring system. This is the first generation deployed over on wastewater treatment applications. It's an extremely low power measurement, so it can basically be deployed anywhere without huge capital cost or energy needs. They're pretty rugged and reliable because you don't have to do maintenance or calibration on the sensor probes themselves. And we've also added the ability to connect other types of standard probes, DO, pH, ORP, flow, stuff like that needed for that sort of wastewater market. The whole system is cellular connected and pushes data up to AWS. And it's sold as this device as a service model where the customer doesn't have to deal with anything. And as cellular technologies change, we just upgrade the hardware. The Gen 2 and Gen 3 systems that are in the field now and coming out in the next year just increase the number of inputs, increase the simplicity, and are more industrially scalable for commercial applications. As we come out of R&D, we have to then beta test and then sort of use these feedback cycles to develop them. We're increasing the precision of the measurement and the temporal resolution to improve AI and machine learning models. And the next gen system is a drop-in replacement for the ones we have out in the field. How we get the data to the customer is based off of open source data platforms. We really love this Redash platform. It lets operators at wastewater treatment facilities or algae cultivation facilities just see what's going on in real time. But on the other side of it, we have open APIs available for direct integration with whatever data tools you're using, or more powerful data science tools like Jupyter Notebooks for testing machine learning and AI applications. Our cloud platform is agnostic. It doesn't care if it's AWS or Azure or Google, but right now we're running everything on AWS. Need to explain a little bit about what this EKG looks like. When we say disruptions, what we're talking about are these massive spikes here that have to do with contamination coming into a water system. These show the microbes getting really unhappy. Normally on the right, you'll see sort of the diurnal processes in activated sludge from aeration. But on the left, this is what happens when the Santa Barbara Airport dumps Bronopol from their airplane porta potties in and disrupts the wastewater treatment process down at Goleta. This technology was used to identify and confirm that it was the airport making these dumps and is now used as an early detection system, early warning system for other contamination events. From a wastewater perspective, the sensor is able to sort of meet or exceed the expectations of other common sensors used in detecting nutrient loading, biocides, or just anaerobic or aerobic conditions. The big thing being no maintenance. We're able to deploy these things up on let's say upstream towards lift stations and other places, so you can get an 8-hour, 12-hour, 24-hour warning before some sort of contamination event is going to hit you, or an increase in biomass or nutrient loading is going to be a problem for your process. Big thing not being optical is that it's not as finicky as some of these other sensors out there that are more selective as to what they can talk about, but there's also not the selectivity issues associated with those types of sensors. This is sort of the timeline of our original R&D. We were looking at environmental applications. We're in a commercial partnership now with Capstone Metering out of Texas for water and wastewater. Potable water and wastewater, and we're looking for new partnerships across environmental, precision ag, and algae. And I'll get into a little bit of the preliminary data we're getting out of there. We've been able to commercially license it in the last year and a half, and you can see the difference in how many deployed systems. As a 5-person team, we really can't handle the level of demand for the wastewater and applications, so that was spun out. But we're still continuing our research, slow and steady, but we're growing and growing, and we're looking at all these other applications. The algae stuff, which is most interesting right now and is the area of the most funding for us from the Department of Energy, we're able to detect both the diurnal patterns associated with photosynthesis, the increase in biomass, but also most importantly, when a contamination event hits an algae raceway basin and it basically eats all the biomass and makes the yield uneconomically viable. This is data from about 3 years ago. There was just early R&D data, and now we are in all 42 ponds, or will be by the end of this year, over at AZ Caddy, the largest algae research center in the U.S. And some of the more recent data we're seeing is that not only can we detect these simple problems of whether or not the microbes are happy, we're also seeing distinct signal patterns differ by strain. So this is a contamination event of another algae, which normally would still have the photosynthetic response and diurnal patterns, but you can see very distinct magnitude, frequency domain changes. And turned out this was a Chlorella vulgaris strain that took over. So we're starting to see distinct signal patterns we can use to discern what's going on in your process and potentially even detect them beforehand. We're also doing algae bloom monitoring across the Central Arizona Canal Project. It's the largest potable water canal system in the US. And we'll be deploying about 20 systems over the next year and a half, but we have 6 in place right now. And we've got some earlier research going on heavy metal detection. And the sensor has a lot of applications as these disruption or unhappiness events correlate with the concentration of heavy metals or other contaminant going in. So this is some earlier stage research that hasn't been commercially developed yet. For agriculture, we just got awarded another grant off of some preliminary data that we can actually use the sensor to 3D image the transfer of charge within plants and soils. We're looking at real-time plant stress for controlled environment ag applications, and this will all be coming out in the next year or two as we get through our R&D grants. We're looking for partnership opportunities. We have deployed our systems at the deepest depths of the coastal areas of Arizona, and by that I mean none. We've got some agricultural applications, but those are a bit slower, but the extreme environments is really where the sensor needs to be deployed next. So we're looking for people there. There's obvious commercial opportunities as we get to the point where the technology has been validated, but if you're looking for potable water and wastewater applications, we can refer you to our partnership with Capstone Metering. And of course, distributors outside of the US is always fun. And if there are any, thank you very much. If there are any questions, please feel free to reach out to me at this email or through Michael. He knows me quite well at this point.
3 great presentations. Evan, I think you take the prize for most improvement from Tuesday to Thursday. Really wonderful, good changes to your presentation. Very interesting. We've been following your company.
Helps, Michael.
Yeah, well, we've been following your company for a number of years, and I think it really is exciting. And I hope some of the other presenters and some of the people in the audience will find ways to work with you. Okay, with that, what I'd like to do is call Phil back, and then if we could ask each of the 3 presenters to also unmute yourselves and show yourselves as well. Then he can bring up the questions and start working with each of you. But we'd like to have kind of just the speakers and Phil on the screen at this point. So 3 great presentations, Phil. Hope you've got some good questions to exercise them, and then we'll come back a few seconds before, 2 minutes before for 9 o'clock.
Perfect. Great. Yeah, thank you for that, guys. Really enjoyed it. Just while we wait for some questions to filter in, I've got a few of my own that I thought I'd chuck out. The first is really to everybody. So Matt, I don't know if your video is on. It's not on my screen, just so you know. There we go. Here he is. Okay, yeah, the first step was really around the cost of sensors and how I mentioned earlier on that there's a need for more data in more places. And that's not necessarily data for the sake of data, but it's around turning that data into information and turning the information into insight. So I wondered if I could just get some of your thoughts really on what you as technology manufacturers and developers can do to support that. Yeah, over to perhaps you first, Matt.
So can I just clarify? So about more data and cost of data?
Yeah, the role of sensor developers and manufacturers really. Is it about reducing costs for the sake of getting as many sensors out as possible, or do you think there's still value in being very specific and high specification?
Okay, so I can give an answer. So I think there's room for both. I think there's a lot of value in just having more data enabled by large numbers of sensors that maybe aren't the best performance, and that can be useful in some applications. But there are a number of areas where if you don't measure to a certain level of precision, then there isn't a market for what you're doing, because you need to be able to have, particularly in some of the sort of science and regulatory markets, you know, if the user isn't able to match with the gold standard method, you're not going to displace that. But having said that, you can do it. The win from having a sensor rather than having to send a person in a van to go and collect a water sample, or even using an automated water sampler, is big, and it's at least 10 times, and it could be 10 to 1,000 times cost reduction for a lot more data. So I think the potential is there, but it's application specific and user specific.
Great. Evan, Charlotte, I don't know if you guys have anything that you want to put into there.
We fight this a lot. I think Matt did a good job of it. It is a trade-off between precision, temporal resolution, and accuracy. And, you know, for the more advanced research we're doing now, we're going to, you know, 20 millisecond sampling rates and hundreds of sensors for some of the more advanced instrumentation, while the wastewater and a lot of the potable water applications, you can do 3 probes with half-hour data and get all the information somebody needs. So, you know, this is very hard to scale for optical technologies. It's a lot easier for, you know, we're doing potentiometric measurements where we, you know, it's just an extra electrode and some electronics, but it is a fight, and it is sort of it's hard to find where we fit in the market when you get to these higher precision tools. So I was quite interested in Matt. Oh, wait, you do real pH measurements, not the electrode measurements that aren't accurate and are basically useless after a few months. So it was quite interesting to see that there, because I'm not seeing a lot of those systems out there commercially available.
Yeah, from our point of view, I guess, you know, the issue with so-called low-cost sensors is that actually you have to look at the through life cost of the deployment period that you're going for. If you look at the through life cost, if you count staff time, vessels, you know, generally the platforms you put the sensors on over time cost a lot more. So whether you're buying, you know, a $10 or a $15,000 sensor, is neither here nor there if you're doing a 3 or 4 year deployment. Those costs will have been written off. And there's a trade-off generally, as everyone's been saying, between quality and robustness, between the cheaper and the more expensive sensors. There is a marketplace for all, but in the type of work we do, at the end of the day, we want to be assured that we're not going to have to put operatives on at sea every second day because the sensor needs to be babysat. So we don't mind paying a bit more to ensure quality and to ensure that our clients get what they look for, which is a stable, robust, resilient, non-drifting sensor.
That's great. And a theme of all of our talks have been around taking away some of the human element, where we're having to send people to dangerous and dirty places and either sample remotely or autonomously. But how have you found it with your clients with trying to change the culture there? Do they very much still want people to go to site despite other opportunities are out there with technology?
Is that for me?
Yeah, if you follow on.
Okay.
Sure.
Well, we primarily do remote monitoring, boys, and we've been doing that since about 2005. So, you know, we prefer to not have people on site. And that's really why we developed the 2 technologies we do, so that our team can manage our assets remotely from their office and go on site in a scheduled way. And if something happens, because things always happen at sea, we deal with it. But most of our clients are fine with automatic data, and actually they see a cost saving mostly over long projects. And there's more consistency. You know, I'll take the SecuDisk example. 5 different people with a SecuDisk will have different data results. At least a single sensor that's the same all the time. You're going to have consistency, And you know, it has to be it has to be good quality controlled data. Our clients pay us for information to manage their infrastructure or their programs or to comply. So it's critical that we give them what is going on in the ocean right here, right now.
Do you find, Charlotte, that with that, you obviously have to go to site to put your buoys and moorings in the water? Do you find that there's a bit of a reluctance from your clients there on the health and safety aspect, or just a cost aspect, and they want to shift towards radar or LiDAR sensing, for example?
So most of our clients are specifically looking generally for static measurements. So it's, you know, to comply with regulations, or if they're doing site characterization in the case of offshore wind, they need to have a specific lat and long. From a health and safety point of view, one of the things that we have here is we're very much focused on getting all our ISOs. So we have 9001, 14001, and 18001 specifically to deal with HSE. Since we started working in marine renewables in 2009, we really took our game to the next level, because that is a very risk-averse sector where data is extremely valuable, and metocean data is required so far upstream for any development. So health and safety is something that we apply across the board in everything we do here.
Great, thanks, Charlotte. Evan, Matt, I don't know if you have anything to input into the remote sensing side.
For water and wastewater, there's no real change in site visits, because you know, you've got these manual samples where biofouling is such a problem, and they need to know their certain measurements that can only be done in a lab for regulatory effluent monitoring applications. So we're not really saving time there, but we are giving better insights with the real-time information they're seeing in context. So we've actually increased the number of times people have gone out to sample, because they've gone out to grab a lab sample when something bad has happened. On other, you know, we haven't done the ocean and water applications. I don't think we're going to make people sample that much more frequently out on a buoy or something. But we definitely see that as a perceived value. But the truth is that when people get more operational insight, they start making more operational decisions.
Yeah, that's maybe we're a bit of an outlier in some of the industries we're targeting, but certainly in the ocean sphere, it's very, very expensive to operate in the deep ocean, and increasingly is carbon intensive as well. So, you know, trying not to send the 6,000-ton research vessels to site is very, very important for cost down for carbon. And so I guess our angle is to try and make the measurements that you would be making with those standard methods, but to a quality that means you don't have to send that asset to site. And you know, doing it that way, you can only ever get so much data. A research vessel can do, you know, 10 transects a year, 100-kilometer spacing of its measurements, and you know, your repeat visit might be every 10 years. So with a sensor, it's relatively easy to do much better than that. But the challenge is making it robust enough and reliable enough, and that the scientists or the regulatory users will trust your data, and that takes a lot of robustness testing and testing alongside gold standards to show that the data lines up. But it's an opportunity. When you then move that technology elsewhere, those advantages of robustness and trust ability, and you know, if it's in situ calibrated and all that kind of stuff, that really helps some users to not have to send people to site. But I take Evan's point, when something interesting happens, actually you might send someone when you weren't thinking of doing so, but maybe you can be a bit smarter about when you do that. It is quite startling, the cost of having someone go to site every day, even if it's in an urban environment.
Great, thank you, Matt. This obviously less applicable to deep ocean science, but I just wanted to ask a question about citizen science and the role that everybody can play really as stewards of the ocean. So your sensors are varying prices, varying complexities and things, but do you think we can get valuable insights through encouraging everybody to get involved with ocean environmental sensing, terrestrial sensing, however it might be. What are your thoughts on that, and should that be something that we pursue further? Evan, perhaps first.
Yeah. Actually, yeah, this is a big deal to me personally. We're open sourcing a lot of our cloud management tools over the next year or two as we develop them with our Arizona State and CSU clients to enable a sort of lower cost access to getting IoT systems to push data to the cloud. But we're also trying to get a sub $500 sort of grad student dev kit put together where we can sort of really bring the cost down of high precision sensing applications with our approach. So we are trying to get there. With AZ Caddy, they're already publishing their data sets and they're being used by various machine learning competition websites like Kaggle. And we're looking at sort of releasing the data sets and APIs to let people sort of come and take a look at some of the algae data themselves. So this is stuff that's all sort of in the pipeline for us as far as opening up access to environmental data. So it's very exciting, but this is 2 to 3 years of work to really get to the ability for some nerd somewhere like me going, oh, this organization's put everything out there and I can buy their equipment for next to nothing. So I'm excited about it, but it's going to be a long while before we can get all these platforms accessible to interested parties.
That really is great to hear, actually, Evan. Yeah, one of the main roles that we have at NOC is around education and awareness. So it's great to see that industrial companies like yourselves are looking into similar things, really. I'll switch now to a question from Aidan in the audience. It's to everybody around deploying systems over time and whether or not biofouling is a concern for you. How does it influence your performance and how do you deal with it? Charlotte, with metocean monitoring, I'm sure that is a big problem for you with certain things.
Yep. So biofouling is a problem in some parts of the world more so than others, and it's also very seasonal. So again, it comes down to the quality of the sensors. We tend to then focus on sensors that have proven biofouling technologies on board, and sensors that can survive for 2-3 months or longer without intervention. So that would be a clear focus of ours, mostly influencing any purchasing decision we have, and it would be a fairly strong influencing factor for our clients as well.
That's great. Yeah, having worked for Fugro for a couple of years out in Qatar, the biofouling out there was unbelievable when I first went there, and I was having to literally chisel and grind it off. I couldn't believe how robust it was.
Yeah.
Evan, you look like you've got something to say on that.
I want to contextualize what I said in chat. For our sensor technology, the biofilm is the sensor. So in one way, it can't biofoul. However, thinking about barnacles now, that may not be entirely the case. So we do need to, for ocean applications, which we're looking for partners for, we just don't know how that would affect things. So I am interested in seeing that, but generally we're pretty biofouling resistant with this technology.
Great. And Matt, producing very high specification chemical sensors, I imagine that's something that's high up on your radar, biofouling.
Yeah, so we use microfluidics. So the liquid channels inside our device is 150 microns, human hair type dimensions, very, very fine. And when I first started this, I thought biofouling was going to be killer within days, but it's been remarkable how long. Well, in fact, we don't see this problem very often. We do put a filter at the front end of the system. And there's the material used in that filter is naturally biofouling, and there are some other things that we do to prevent some of the fouling on that. And we've only ever seen 1 or 2 in very, very turbid environments where fouling has become a problem. It's not so much biofouling, just fouling, but that can be managed by backflushing filters and or larger filters, for example. I guess we're lucky in that we are using reagents in a channel which are not necessarily conducive to biofilms. But yes, we thought it was really going to be a killer, even in those sort of horrible estuarine and high biofouling environments. The sensor on the outside gets all hairy, but the measurement is relatively is unaffected because we're carrying standards, and unless you're changing the chemical nature, we don't see much. If you've got a very stagnant environment, if you're trying to measure nutrients and you've got very heavy biofouling, then the biofouling may actually be taking up nutrients. But we have been not able to detect that even with very high fouling in the standard, relatively static tidal estuary. So surprising how it's not as bad as we'd feared. But
Yeah.
there are some things we need to do. We do some active biofouling control.
That is surprising to hear, Matt. It's great to hear. Yeah, having spent many days on research ships, bringing your kit up from the seabed after 3 or 6 months and seeing that it's only got a fortnight of data in there because it's been clogged up, it's good to see that you're not having the same impacts on what you're doing. We've got another question in the chat from Martha, which says, what's the ideal and what is ideal and cost effective for monitoring wetland water quality in rural areas around the world? Matt, I know you've worked, or your team has worked around the world with in various applications. I don't know if you're well placed to perhaps try and answer that one.
Yeah, so really important environment, wetland environments, and so we've been doing, I guess it's more akin to the citizen science question that you popped earlier, but we've been doing a lot of work for overseas development assistance recipient countries, you know, working in Seychelles, Belize, Fiji, and what we find is that because our systems are very robust and they are, you know, portable, you know, you can carry them in a backpack and the data systems can work, that they can go pretty much anywhere that you can take them, and then they will then produce reliable data. So if our sensors cover what you're after, then it's quite a good solution, and they can be thrown in. Some areas of the world we have to make sure that they've got security protection before they get pinched, but otherwise, you know, they're pretty robust in most of these environments, and you get some very nice data. You know, interesting tidal and wetland systems because of the different hydrological and chemical interactions that are going on there.
Thank you, Matt. We have another question, which is aimed at Matt and Charlotte. Do you find in the UK and Ireland that the robustness you've proven in one area is trusted in others? So that, I suppose that can really be applied to geographical areas and also different industry sectors. But if we focus on geography first, please, Charlotte, to you.
Totally. You know, Ireland is a small place, but we have a really bad climate. So from the in situ point of view, you know, the fact that we can survive 11, 12 meter waves, HMAX, and it's business as usual is good. Now, the problem is we have to wait for those events to happen. I think today we have 5 meter waves here in Dublin Bay, but those are the days that basically show that your technology is robust. By the same token, developing Earth observation services and linking it in with the in situ data. Earth observation is portable anywhere in the world, yet ocean color doesn't see through clouds. So in a way, when you're able to overcome challenges and develop product processing chains over here, you can then, you know, you can export them into other sectors, both geographically, but also markets.
Thanks, Charlotte. And you, Matt, what do you think on it?
So I think standards, so our standards are in numbers, and then there are some ISO standards around the sort of metrology practice that you have to get to those numbers. But we do find culturally some people will take data that you present them in a data sheet and others won't, and others will want to do their qualifying tests in their environment, in their country, against their standards themselves. So it's a bit of a mixed picture. but many places will just take those transfer standards as written.
Okay, thanks, Matt. I had a question myself for you, actually, Matt, around obviously you're a fairly new company, being a year or two old now. How easy have you found it to enter established markets as a startup? It's obviously been a challenge of sorts, but what are the key challenges that you've had to overcome there? And do you have any tips that you can share with people on the call?
So it's interesting, it's very market specific. I really like the scientific market because you've got a lot of very enthusiastic early adopters who've already read the literature, and so they're pretty confident straight away, and that's very helpful. But in other markets, the antithesis is true, right? They've not read the literature, and they're very conservative about new methods. And there, I think we're discovering that it's important to have partners who are already trusted in that industry, and to be patient, to be able to do demonstrations and bring people with you. We found once you get into one market though, and somebody's happy with you, then it becomes a lot easier. You've got a demonstration use case, and actually most of these industries, they all talk to each other and word gets out that it does work, and then you're off. But I think be prepared to be patient, but try and have an early adopter market that you can perhaps rely on early on to just grease the wheels a little bit.
Brilliant. And hopefully, yeah, you've benefited from the association with the NOC and Burge Environmental. In fact, Evan, if I could throw that over to you, have you had any interactions with research institutes in the history of your business being slightly more long-standing so far? And any thoughts following on from what Matt's just said?
So I was not part of the company when they were working on their various radiochemical detection systems, which, as you might imagine, are some of the most terrifying regulatory compounds to be developing sensors for. Those have been problematic when we've done beta sites, even with early adopters who want them, because they give information nobody wants to hear. On the wastewater side, however, because it's an industry that is kind of happy our new sensor doesn't tell them exactly what the problem is, they're less worried about the regulatory issues. So we've sort of been on both extremes. We've had a system taken off site for I think technetium-99 detection because it gave bad news, and we have a system that's a couple systems now being used to keep the regulators off people's back. So it really does depend on the creativity and sort of imagination of the engineers and scientists you're working on, who are your customers. Whether or not they're going to say, oh, well, this doesn't give me the spec I need, this doesn't help me with the effluent parameters the regulators care about, or this is giving me information I need to make a better decision. There's some language in the EPA regulations about best possible technology, which sort of gives you this open-ended interpretation. So if you're working with a regulator who is familiar with that, they're a little bit more open to the novel technologies and not necessarily giving us the grief Matt gets about which standard he's using for his analysis. So it's both. The wastewater side, we don't really talk about detecting specific things, because if it's an effluent parameter, it doesn't help our customers, but telling them when to go sample for that effluent parameter helps a lot. So again, that's why I get into, we actually make more work for our customers, but they seem to like it.
That's good. You've raised a couple of good points there, Evan. Creativity being one that I've particularly picked up on there, and without that, a lot of these things just wouldn't get off the ground without that sort of blue sky thinking to kick things off. I see Michael's appeared on our screen, so I imagine you're going to take the reins back for now.
Well, unless you have any closing comments, Phil, I mean, this was really a joint event with the NOC, and I think you did a great job really with the questions. And of course, the fact that Matt is there, I think also speaks volumes about the direction of the NOC to be very relevant, to be spinning technology out, and the outreach that you talked to at the very beginning. Any last comments you'd like to make?
Only really that it's been great to hear from everybody. The work that we've done with ClearWater has been a real flagship for the NOC, so it's great to see them getting off the ground running, really. And it's been brilliant to hear from Evan and Charlotte on further developments with their industries and their companies. So thank you for having us, Michael. We've appreciated the invite to co-host this with you, and hopefully do it again soon.
Good. Well, if I could, while Tamara brings the last slides up, I wanted to say, Matt, it looks like it'd be hard to talk underwater the way you are. I mean, it's very pretty, but I feel like there should be fish all around you or something. So thank you very much. Great presentations. Tamara, if you can bring back up our slides, and once again, we'll show the speakers. Okay, so here are take a quick screen snap for those of you that would like it right away. All three companies are doing great work. One of the fun things we always do when we do our demo, our dry run, which we usually do 2 days in advance, was we ask them if they see ways to work together. And it's always great to kind of listen as they brainstorm about seeing other innovative technologies and service providers and ways they can work together. And it's one of the great things that happens with BlueTech Global Connect is companies that may not have known each other, particularly because we're focused on small to medium-sized companies, get to talk about their innovation, and then hopefully people in the audience, but also the other presenters can hopefully find partnership opportunities. So to all of you that have come with us today for this little journey, thank you. Tell other people about it. Tell them to go to the website, our YouTube channel. And I think, are there any other slides tomorrow, please? Yep, thank you again for participating, and register for our next event in June. Thank you to our partners, the BlueTech Cluster Alliance. We work with the Brink at the University of San Diego. Next month will be Tamara's last time with us. In fact, she leaves the day after our seaweed event. So to Tamara in advance, we really appreciate all the work you've done. So thank you to all of our attendees, our speakers. Guys are great. That's what makes the BlueTech Global Connect so successful. So thank you very much, and we look forward to talking to you very soon.